Hello, my name is Moses Ajay. In this session, I'm going to be covering the SI units, area, volume, and flow rate. And at the end of the session, you should be able to you should be able to complete simple calculation involving area, volume, and flow rate. SI unit. It is referred to as International System of Units adopted in 1960. There's several properties, but we're going to be looking at seven physical properties, and the basic and these are considered to be basic units. And we have a length, we have a time, we have temperature, we have mass, we have electric current, we have luminous intensity, and we have amount of substance. We have these are seven physical properties that are considered to be basic units. And in this lecture, I'm going to be focusing on length and time. Later on in the program, you will be doing something on temperature, mass, electric current, luminous intensity, and amount of substance. Now, focusing on length and time. Now, let's look at this. Now, this is talking about, now you can see, I could express my 1 decimeter as 0.1 meter. This could be once, and at the same time, I could say 1 centimeter can be expressed as 0.01. These are standards we should know. These are standard that 1 decimeter equals 0.1 meter, 1 centimeter equals 0.01 meter, and 1 millimeter equals 0.001 meter. These are meter equivalents in three different units. But we know that meter is our SI unit. So the reason for having SI unit is for scientists to be talking in the same language. Now, people have different names, but sometimes, in order to make things easy for ourselves, we call ourselves by first name, and in some scenario, they might be calling themselves by surname. But if we have a standard in this company, this is what we'll be doing. We'll be calling ourselves with first name. So similarly, in calculations, we have what we call SI units. Now, a substance, for example, we can have our length to be in meter, our length can be in centimeter, our length can be in kilometer, can be in miles. So we want to have a scenario whereby when we are combining length and time together, or combining distance and time together, or combining velocity or anything with time together, we want to be able to do that using SI units, so that what I'm saying in essence is that when you're doing your calculation, it's always good to do it in SI unit, except you are asked to do it otherwise. So, for example, we could have area, and our area can be measured, for example, in length, in centimeter, and our okay, this is square, so we know length equals breadth for square. Now let's go to the rectangle. We have now, for example, the length of a rectangle can be measured in meter, and the breadth can be measured in centimeter. And if you want to find the area, we cannot just say 2 meter multiplied by 3 centimeter. It's not possible. We need to convert, for example, maybe convert the meter to centimeter, or convert the one in centimeter to meter. Now, and the practice is always to convert the one in non-SI unit to SI unit. That's the practice. So the reason for having SI unit is so that when you're doing your calculation, you can convert it to the SI unit, or if you're asked to do it otherwise. Some parameters can be measured in non-SI units. You need to, and if you are going to use it in a formula, try to convert them to SI unit. This is very, very important. We'll demonstrate this as we go. Now, for example, a square measures 5 centimeter by 5 centimeter. Now, maybe in an exam, this can be a square measures 5 centimeter by 0.05 meter. Now, you could see deliberately we've given the length of that square into, although they are the same in unit. Sorry, they are the same in terms of in magnitude, but we've given them in this scenario, it is given in centimeter. But I'm just making I'm just citing an example whereby you have parameters. I think we should have that example. Let's just go on. I will show you that example later on. Now the question says calculate the area of the square in centimeter square, in millimeter square, and in meter square. Now, if I want to solve this problem, for example, to do the area, we know area of a square is going to be length times length, and that is going to be straightforward. For the first one in centimeter square, it's going to be 5 centimeter square multiplied by 5 centimeter square. And what do we get? What do we get for that? We get 25 centimeter square. That is very straightforward. Now, to calculate the area in millimeter square, now don't forget we are given the length in centimeter. So what I would do will be to convert this to millimeter first. If I convert to millimeter, then I know they are the same thing. So I multiply that straight, I get my millimeter. Somebody would say, no, Moses, I don't want to go that approach. Once I've gotten this, I will convert my centimeter square to millimeter square. Yes, that's another approach. It's good. You can use that approach. But the reason why I suggest that we convert this 5 centimeter to millimeter is because if we've made mistake in this solution, in this calculation, in this computation, that mistake, if we convert this to millimeter square, that mistake will be automatically carried over to this to question number 2. So in order to avoid that, I would prefer maybe converting the centimeter to millimeter and then use that to calculate my area. So that's what I do. That's what I would do. So and I think we also need to remember that 10 millimeter equals 1 centimeter. Now what that one is saying is that every 10 millimeter you have, that's a centimeter. Now we have 5 centimeter. Therefore, our 5 centimeter will be what? 50 millimeter. Every centimeter equals 10 millimeter. So 5 centimeter will be what? 50 millimeter. Don't forget that. Once we've done the conversion, all we just need to do is just to multiply. Area in millimeter square will be 50 millimeter multiplied by 50 millimeter. And you have 2,500 millimeter square. Now to do this in meter square, now what we need to do is to convert the 5 centimeter to meter, to a particular magnitude in meter. And what we need to remember that 100 centimeter equals 1 meter. So when we remember this, that 100 centimeter equals 1 meter. Now what this one is saying in essence is that every meter you have equals 100 centimeter. Now we have 5 centimeter. So 5 centimeter is going to be 0.05 meter. Now you see 100 centimeter equals 1 meter. So 5 will be less than 1. 5 centimeter will be less than 1. That is the indication. And if you're not less than 1, so you need to divide by 100. So you divide that 5 by 100. So it's like saying 100 centimeter equals 1 meter. So 5 centimeter will be 5 divided by 100, which is 0.05 meter. So we have that in meter. So what we need to do to calculate the area in meter square is to multiply them, and you have the area in meter square. Now, these are practice questions for you. Now, you've been asked to calculate the area of the following and give your answer in centimeter square, millimeter square, and meter square. Just following the same thing we've done. Now, this is what I'm talking the other time. Now, you have a square. Now, a square of 1.5 meter and 150 centimeter square. You can see this is intentional. They mean the same thing. So just take note of that. Now look at this rectangle, 30 centimeter, 150 millimeter. It is not possible. We cannot multiply them directly. It is just like saying you have £2, $2, and we say the answer is £4. When we add them together, it's not possible. We cannot add them together. We need to convert one to the other before we can manipulate the figures. Okay. Now for circle, area of a circle. Now the same procedures. All you just need to know is the formula to calculate the area of a circle. For example, we've been given a circle of a radius 15 centimeter square, and we want to calculate the area in centimeter square, in millimeter square, in meter square. Same procedures but different formula. Now we've been given the area. The radius of 15 centimeter, and don't forget your 15 centimeter using the conversion I mentioned earlier will be 150 millimeter, and at the same time using the conversion I mentioned earlier will be 0.15 meter. So don't forget that. You need to convert, you need to know the basic conversion. If you know that, you will save yourself of making some of mistakes. So we just need to know that conversion is very, very important. You might want to pause here and try to go over this again by calculating it yourself, so that you are sure that you understand the conversion process. How 50 centimeter equals 150 millimeter, and how a radius equals. So if you pause now, do the conversion 15 centimeter to millimeter and 15 centimeter to meter. If you pause this video now, then if you start again, you have this answer. Okay. Now we've computed the radius in centimeter, so in millimeter and in meter. We've been given the radius in centimeter. All we need to do is just to write the formula. Area equals pi r square. So we have our pi to be 3.14. It can be 3.142. It can be 22/7. Whatever you are given, use it. If you are not given any figure, use 3.142 for example, or use 22/7. So it's, and then in centimeter square, we use the radius in centimeter square, which is 15 square. Put that in your calculator. You have this 706.50 centimeter square. Same forward for the millimeter. Put 150 millimeter here. So at the end of the day, you have your answer in millimeter square. And at the same time, in meter square, use the radius in meter. You have this as your final answer, 0.07065 meter square. So if you could also do the conversion if you want to do it. But let me just remind you, I said earlier that 10 millimeter equals 1 centimeter. Remember, I said earlier that 10 millimeter equals 1 centimeter. That is what we use here for the conversion. If you are converting the area, do not forget that it's going to be square. That 10 is in two places. So centimeter to millimeter, you will need 2 tens. 210, which is 100. You will need 10 square. That is what I mean. You will need 10 square, which is 100. So that shows that if you look at the difference between the two, you discover that this has been multiplied by 100. It is not by 10. It is not by 10. You could say, we should have multiplied this by 10 and you have 7065 millimeter square. No, because this one is in square. So that 10 has to be in square. That is going to be 100. 10 multiplied by 10. So if it is in volume, is in cube, that 10 has to be multiplied by itself in 3 places. 10 multiplied by 10 in volume. So if it is centimeter cube, meter cube, it has to be in 3 places. Take note of that when if you want to use the approach of converting your final answer to the next unit. Just take note of that. I hope you understand. Good, thank you. So these are practice questions for you. Same procedures. Try to solve it. Following the same procedure, 25 centimeter radius, 1.5 radius, 150 millimeter radius, and you want to calculate your area in centimeter square, millimeter square, and meter square. All right. Here, don't forget what we need here is, if you say a pipe of radius, we need the cross-sectional area of the pipe, not the area of the pipe, please. So we need the cross-sectional area of the pipe. Thank you. Now, going to volume. Volume. When you're talking about volume, is in 3 dimensions. Now, this is a key. No, the length, breadth, and height are the same. This is a keyboard. They call it an obligon here. So we have oblong. We have the area. Volume. The length multiplied by breadth the length multiplied by breadth multiplied by height. So you have that, and for cylinder, this might be a cylinder, this might be a pipe. If it's a cylinder, you could say this is height. If it's a pipe, you could say this is length. It doesn't really matter. It can be H, it can be L, it can be height or length. So don't forget that. So the volume of a cylinder, the formula is something that you need to remember: pi r square H. So your pi is 3.14, r is your radius, H is your height or the length of the pipe. Sorry, this is not off. This should be height or length of the pipe. So Now this is an example. A cube measured 20 centimeter by 20 centimeter by 20 centimeter. Calculate the volume of the cube in centimeter cube. Multiply it straight. 20 multiplied by 20 multiplied by 20. You get the answer in centimeter cube. In millimeter cube, all you need to do is to convert this one first to millimeter, which is going to be 200 millimeter. Then multiply 200 by 200 by 200. You get the answer in millimeter cube. In meter cube, convert this to meter, which is going to be 0.2 meter. 0.2 meter, 0.2 meter. Multiply by themselves, you get your final answer in meter cube. Okay? Try this, and you discover that it's very simple. Now, SI unit for volume is meter cube. But we know that in many in the industry, the unit of volume is often expressed, the volumes, they are often expressed in liters. And how do we rectify this? What you need to know is that 1 milliliter equals 1 centimeter cube. So the SI previous for centi is 10 raised to the power minus 2. Now, every centimeter you see is 10 raised to the power minus 2. So therefore, 1 millimeter here will be 10 raised to the power minus 2 because it's in 3 places. 10 raised to the power minus 2 number 1, 10 raised to the power minus 2 number 2, 10 raised to the power minus 2 number 3 meter cube. Don't forget I said that earlier because this is cube. So that preface of 10 raised to the power minus 2 will be in 3 places. If it is just in centimeter, you need it in 1 place. But now it's in cube, so you need it in 3 places. Do not forget that. And 10 raised to the power minus 2 multiplied by 10 raised to the power minus 2 multiplied by 10 raised to the power minus 2. Apply the laws of indices. Remember our laws of indices? You take the base, then minus 2 plus minus 2 plus minus 2. Because this is multiplication, it's going to be plus, plus. And don't forget, when you add minus 2 plus minus 2, that will be minus 4. Plus another minus 2, that will be minus 6. Don't forget that. It's like adding negative to negative. Now somebody is owing minus 2 and is also owing minus 2. It's also owing minus 2. Let's say this is owing minus 2 in NatWest Bank, minus 2 in Lloyds Bank, minus 2 in HSBC Bank. So all of the debt will be what? Minus 6. Don't forget that. So when you apply your law of indices, you have this. I don't need to be going through the laws of indices now because we've done that. And where we are now is that we can confidently say that our 1 milliliter equals 10 raised to the power minus 6 meter cube. Now let's take this a step further. Now don't forget we have 1 milliliter equals 10 raised to the power minus 6 meter cube. Now this is what we have. So we want to take this further now. Now if we multiply this by 1000, so you have 1000 milliliter. Okay, now multiply this also by 1000, okay, meter cube. So 10 raised to the minus 6 multiply. Look at it, the equality sign is still preserved. I've only multiplied this by 1000. I also multiplied this by 1000. So all I've added here is 1000, and here is also 1000. So the equality sign is still preserved. Okay, now milli is 10 raised to the minus 3. So milli is 10 raised to the minus 3. Now this liter is not liter cube. Now don't miss this. Don't please avoid missing it up here. Now this liter is just 1 liter. Is L. Is not L. It is not L cube. So that is why I only said that my milli is 10 to the minus 3, and 10 to the minus 3 is like dividing it by 1000. So this milli will cancel 1000. So you are left with 1 L, 1 liter. So our 1 liter in essence equals 10 raised to the power minus 3 meter cube. Now don't worry if you don't know how to do the conversion, but you just have to remember that your 1 liter equals 10 raised to the power minus 3 meter cube. And if you are interested in knowing how to do the conversion, feel free to contact me. Therefore, to convert volume in meter cube, which is cubic meters, to liter, we multiply our meter cube by 1000. Now this is just explaining this. Now if you want to convert your volume in meter cube, now your volume in meter cube to liters, we simply multiply by 1000. Now, what this is saying in essence is that if you have a volume in meter cube, for example, if you have one meter cube, your 1 meter cube equals 1,000 liters. That is what I'm saying in essence. Your 1 meter cube equals 1,000 liters. So if you look at this very well, 10 raised to the power minus 3. Now look at it. If you multiply both sides by 10 raised to the power 3, that is 1,000. Multiply this by 1,000, you have 1,000 liters. Multiply this by 1,000, this will go, you have 1 meter cube. That tells us that 1 meter cube equals 1,000 liters. 1 meter cube equals 1,000 liters. So if you are giving the answer in meter cube and you want to calculate it in liter, so all you need to do is just to multiply it by 1,000. So in meter cube, if you to convert volume in meter cube to liters, all you need to do is just to multiply by 1,000. You need to remember this. Okay. Example. We want to calculate the volume of a pipe 1.2 meter high and a diameter of 50 centimeter. Now, solution. Now, the very first thing I want you to notice here is your meter, the height, the length of the pipe, or it might be the height of the pipe, depending on the position, how you position it. Might be length of that pipe, it might be the height. So you can see me changing it, interchanging that. So it's just for us to understand that when you have a pipe, you could describe the height as same as length. Really, you could, if it is horizontally placed, you simply say it's length. If it is vertically placed, we will say it is height. So it doesn't really matter. All you need to know is it has to be used as your h, not as your radius. So this is where we get our radius diameter. We get our radius from 50 centimeter of diameter. So let's go now. Don't forget there are different units. We need to now do the conversion. Volume of a pipe equals pi r square L or pi r square H. I've said that earlier. So our L is the length of the pipe. Our R is the radius. So we have pi equals 22/7, 3.142. Our R here is equal to 0.5 divided by 2. Now we have our diameter as 50 centimeter. We've converted that to meter, which is 0.5. Now we need R divided by 2. Your diameter divided by 2 is your radius. So we have 0.25 meters as our radius. And our L is already given to us in meter. So we just need to put that in the formula. 3.14 multiplied by multiplied by pi r square, pi r square, 0.25 square, multiplied by h, it's 1.2 or L. So which is your height or your length. So when you put that in your calculator, you get the volume of the pipe to be 0.2355 meter cube. Now, another thing I think I should let you know is the flow rate. Now, most of the time in the industry, we want to know the flow rate, not the speed of the liquid. But now, assuming we've been given information on the speed or the velocity, and we know that is measured in meter per second, and we want to find the flow rate. Now we have the speed. Now the flow rate has to be within a confined area. In this scenario, pipe, for example. So if we're talking about the flow rate, now we are really interested. If you look at this is speed. Speed is telling us the distance covered for every second, meter per second. When you see meter per second, that tells us that what is the distance covered in every second. Now, we've been given the cross-sectional area of the pipe. Now flow rate of a pipe will be a function of the speed, distance covered for every second, not just that alone, and also the cross-sectional area of the pipe. If the pipe is very wide, you expect the flow rate to be big, to be higher. You expect the flow rate to be different if the pipe is very wide, and we expect the flow rate to be different if it's a thin pipe. Now, what I really want us to know is the flow rate is volume per unit of time. So we have the distance per unit of time. Now, to bring in the volume, we need to multiply by what? Area. When you have the distance, the length of the pipe, You have the length of the pipe. Now to bring in the area, we need to multiply the cross-sectional area of the pipe with the speed. So in essence, what I'm saying in essence is that your flow rate is defined by cross-sectional area multiplied by speed. Once you remember this, you are fine. Now let's look at our example. You've been given you want to calculate the cross. You've been given the speed to be 1.13, and we'll be given the diameter to be of the pipe to be 25 millimeters. So our R equals 12.5 millimeter. Or now we need to convert that to what? To meter. So we have divided by 100. So we have it in, sorry, divided by 1000. Sorry. So we have it because we are moving from millimeter to meter. So we need to divide it by 1000. So we have the area in meter. So the cross-sectional area is the same thing as the area of a circle. So area of a circle is the cross-sectional. We are talking about a pipe. So a pipe, a circular pipe. Now we assume it's a circular pipe. So the cross-sectional area here is pi r square. So our pi is 3.14. Our r is 0.0125, and we want to square that. So we have the cross-sectional area to be 0.0004906 meters square. Now, but our interest is to calculate the flow rate. Now, the flow rate will be cross-sectional area multiplied by speed. So when you multiply that, don't forget, look at the meter square multiplied by meter with meter cube. So that is why you have your flow rate in meter cube per second. Use your calculator, multiply these two elements, this one and this one. You have 0.005544 meter cube per second. All right. So that is the question we've just solved. Now, if a fluid is flowing, a fluid flows in a pipe at the speed of 1.13 meter per second, and this is what we have, and the diameter of that pipe is 25 millimeters square. Calculate the flow rate in liters per hour. Now, we've solved the problem. We've solved the problem not in meter. We've solved the problem in meter cube per second, but the question says we should solve the problem in liters per hour. Now I'm going to leave that for you to solve. Now please contact me after solving this problem. You have your flow rate in meter cube per second. Now I'm giving you the problem to solve. Express this in liters per hour. Now use the conversion principle I've mentioned earlier. Convert this one to liters, convert this one to hour. So if you convert your meter cube to hour, convert your meter cube to liters, and convert your seconds to hour. Don't forget that 60 seconds equals 1 minute, and 60 minutes equals 1 hour. So that tells us that 3600 seconds equals an hour. So use that expression to convert your seconds to hour. And don't forget, your seconds here is denominator, and your meter cube here is numerator. Please take note of that. It's very, very important. Take note of that your seconds is in the denominator and your meter cube is in the numerator. Please do some research on this and do this conversion for me. Okay. Now, in this recording, we've covered calculation involving area, volume, and flow rate, and we've talked about SI unit and how to convert the unit from one to another. Thank you. And if you have any question, please do not hesitate to contact me. Remember, you're just an email away from us. Thank you.